Welcome to part 3 of our ADIAT version 2.0 launch spotlight. In part 1, we looked at the image analysis setup process. In part 2, we looked at the image viewer. And now in part 3, we're going to talk about ADIAT's brand new streaming capabilities. So historically, ADIAT has been focused on image analysis, which is by nature a post-processing event. You take the drone up, you have it fly, usually some autonomous flight plan, bring it back, and then you process the images looking for areas of interest. Once we move into streaming, we still have the ability to process files, so still do post-processing, but there are a couple other mechanisms in place with HDMI capture and RTMP streaming that allow us to use ADIAT in real time, which, as you can imagine, opens up a whole new world of possibilities of when ADIAT can be used in the field. So with that, let's dive into how the streaming side of this works. I have ADIAT open here, back to our landing page, and now instead of clicking on images, I'm going to go ahead and click on streaming. And just like on the image side, you're greeted with a wizard view to set up streaming. So same concept here, as I said, as we had on the image side. We want to make this approachable to new users. You'll see once we get to the streaming viewer, there's all sorts of settings that you can configure and really have full control over the algorithms and the processing and all those things. But we wanted to make this approachable to somebody coming in for the first time and really just getting started with, in this case, video analysis, looking for anomalies or looking for specific colors. So just like on the image analysis side where the wizard kind of breaks it down step by step and asks some questions, we do the same thing to set up streaming. So the first question you're greeted with here is what is going to be your source for streaming media? Are we going to be looking at a file? Are we going to be looking at HDMI capture? Or are we going to be pulling in a video from an RTMP stream? For the purposes of this demo, we'll go ahead and leave it as file for now. So I have file selected. I go ahead and click continue. And then, as you might expect, it asks me, hey, where is this video file that we want to process? So I'll click on browse and I'll go over to my demo video I have set up. And that brings it in there. And the next question asks is, do we want to auto connect as soon as the guide finishes? And that question may make a little more sense once we get into the viewer. But essentially what it's asking is, hey, as soon as we finish configuration, do we want to immediately start the video and start processing? Probably makes a little more sense for the HDMI capture and RTMP streaming scenarios where there's just a feed of data coming in. Whereas with a video, you're probably more likely to want to open the interface and hit play yourself and start the video that way. Last question on this screen is our processing resolution. So just like on image analysis, where we have the opportunity to do some downscaling to improve performance, we do the same thing on the video side. However, it is probably more pertinent on the video side. So since we're doing this in a lot of cases for real-time analysis, we're going to run into a lot of situations where just because of the nature of the algorithms, the nature of the CPU and computing power required to do the analysis, we're going to be better off doing a little bit of downscaling. A lot of this is going to come down to the capabilities of your particular computer, and in some cases, the resolution of the input video itself. I believe all the DJI controllers at this point, when they're streaming video back from the drone to the controller, are maxed out at 1080p anyway, so there's no reason to go above that from a processing resolution standpoint. RTMP is probably capped at 1080p as well, if not lower, so just something to consider. Just because we're not at 4K doesn't mean we're really losing anything. Chances are the video that's coming in, if it's not coming from a file, isn't going to be 4K anyway. So I'll go ahead and leave this at 1080p and go ahead and click continue. Now we have some information we're gathering about the image capture. So we saw this on the image analysis side where we we're able to automatically pull in information about the camera and drone being used in AGL. Unfortunately, we don't have that luxury with video. That information isn't captured in the files, the MP4s, or certainly with a streaming system, the same way it is on the image side. So we have to go in there and configure that manually. You'll see if you click in here, there's a whole list of supported drones and cameras that are available, and you can always click on other if none of these match. The good news is this isn't actually critical to the actual processing. This is all just like on the image analysis side. This is all about getting the right min and max object area. So we're trying to use the information about the camera, use the information about the AGL altitude to calculate estimated ground sampling distances. So we can use that as we calculate our min and max object areas. So that being said, I'll leave this at the Matrice 4E, which is what I was flying, and I was flying right about 100 feet AGL. And again, you see down here, that will calculate our estimated ground sampling distance for us as we change that value. I'm actually going to set it at 150. We'll go ahead and click continue. And then we're back to, hey, what is it we're actually looking for? What is the size of the objects on the ground that we're trying to find, in this case in the video? Is it a small article, again, like a hat, helmet, something of that size? Is it something the size of a cat or a day pack? Is it a large pack or a person standing up? Is it a person lying down? Something bigger than that? Try to get a sense of the size of what we're looking for, because it will change some of the parameters and what we automatically set in the video analysis. So I'll go ahead and leave that with the defaults. And now we are to our algorithm selection. So on the streaming side, we have two algorithms available in ADIAT version 2.0. There is a color specific detector, and then there is a color/motion anomaly detector. And you can either use color anomaly alone, motion detection alone, or a union or a fusion of those two. So for now, let's go ahead and say we are not looking for a specific color. And just like before, it gives us the algorithm recommendation. Now, there's only two options, so there's only that one question that comes into play. Are you looking for a specific color? If you are looking for a specific color, it'll recommend color detection. Otherwise, as I said, it'll recommend color anomaly and motion detection. We'll click continue. And now we have two question sets, basically. One is, hey, do we want to enable color anomaly detection? The other is, do we want to enable motion detection? If we motion detection is strictly a yes/no question for the simplified setup process through the guide. Color anomaly detection asks our aggressiveness question again here of, hey, how aggressive do we want it to be in finding anomalies? Do we want to be more aggressive and have more false positives? Or do we want to be more conservative and have fewer false positives, but the potential of missing something of interest? That is the extent of the setup through the guide. If I were to click Open Stream View here, it would take us to the stream viewer. Just for the sake of seeing what the other side of this looks like, if we say, yes, we are looking for a specific color, our selected algorithm is the color detection algorithm. We click continue, and much like our color detection algorithms on the image analysis side, we have the opportunity to add colors. And if you click on this, you may see that, or may recognize that the options here align with the HSV color range algorithm on the image side. And that kind of gives you a little bit of a peek behind the curtain. We are using an HSV color detection system for video, just like we have with the color range HSV image analysis algorithm. So with that, we have our HSV color picker. If you saw video 1, you've seen this before, where over here on the right, we select our hue and hue range using the hue circle here. So if we're looking for something blue, we set the bar on our base color, and then we set our range from there. Over on the left, we can go ahead and expand or contract the saturation and value box as we see fit. If we go down here, we can say pick from an image. That takes us to the HSV specific color selector, where if we pull up an image, and again, we've seen this on the image analysis side, control click and it will select that color for us. As we select more colors, it adjusts the range for us, essentially defining a range that encompasses all the colors we select in the image. If we were to select something like over here that is way outside the blues we've seen, it'll give us a warning saying, wow, that's a really wide range, but it'll go ahead and do it anyway. If we were to click OK, you see it comes all the way around. So it will do whatever you do or whatever you tell it to do, but just know that if you start selecting colors that are all over the place, you're going to end up with a really wide hue range over here. So let's go ahead and back that back down and click OK, and then we see that color added here. Just like with the image analysis, we can select multiple colors. These colors, well, let's pick a completely different color so we can see them side by side. We have our match tolerance question here. Again, back to our aggressiveness question, essentially. How wide or narrow do we want the match tolerance to be for this specific color range? So if we set that and go into view range, we see the two ranges that it would go ahead and match for us. And that's pretty much how we set up the color detection side of this. Let's go back, reset that, go back to anomaly, color anomaly and motion detection, click continue. Let's say I want to go ahead and be fairly aggressive with the color anomaly detection, and I'm going to go ahead and leave motion detection off for now and click open stream viewer. Now, if I had gone ahead and say automatically connect, then the video would start playing here. I said don't do that quite yet because I wanted to show the interface a little bit before we get to that. But the next step in the process would be to click the connect button here, which will load the video here. Now, before we do that, let's do a quick walkthrough of the rest of the interface here in the viewer. So up at the top, we have our menus. We can get back to that analysis setup wizard if we want to. We can jump over to the image analysis side of the house, or we can get to our same application preferences that we have in the main window for image analysis. On our help menu, we have the link to the user guide. We have a link to the community forum, which is on Discord, and we have a link to the YouTube channel where you are watching this video. Down here, we have our live video, and then we have gallery mode. So if you watched part 2 of this series, you saw gallery mode in the much improved image analysis viewer experience. Same sort of thing here. Gallery will show you all the thumbnails through the history of the detections of the video. So if there's a detection, at 33 seconds into the video, and then you're watching for another 2 minutes, you can go up to the gallery and you'll still see that detection from 33 seconds, and you will be able to click on that. And if it's a video or a stream that is being recorded, it'll take you back to that. So in case you missed something or in case you want to revisit something, you can switch from live view over to gallery and see previous detections. Moving over to the right side here, we have our stream connection set up. So analogous to what we just did in the wizard, we can change from file stream to HDMI capture or RTMP. And if we do change, sorry, there's a bit of a delay going over to HDMI capture simply because it's looking for HDMI capture devices. So it may seem like the application froze up there. Really, it was just scanning the hardware to make sure or to identify any HDMI capture opportunities. RTMP, it asks for a streaming URL. There's all sorts of guides out there that talk about how to set up an RTMP stream. I highly suggest you look at that if that's something you're interested in. It definitely does have a little bit of a setup process that you have to go through, but the big payoff there is that you can do analysis offsite. So basically, you stream from your device, from your drone or controller to some sort of media server, and then from the media server to ADIAT. But let's go back to file for now. I'll pull back up my video. Down here, you'll see some performance statistics as the video is playing. We'll see resolution, frame rates, how far we're into it, how many frames we've seen, how many detections. Again, just some metrics and statistics about the performance of the video. Down here, we have our algorithm selection. So we have color anomaly and motion detection, or color detection. Let's stick on color anomaly and motion detection for now. Gallery threshold, so this is how many frames does the detection have to be in before it's added to the gallery. Just gives us a little bit of a buffer. If we set it to 1, then literally every single thing that it finds would immediately show up in the gallery. Setting it to something like 5 gives us a little bit more room to say, okay, if it's there for 5 straight frames, it probably is a legitimate detection, not some sort of false positive, and then it will put it in the gallery. Down below, we have some tabs with various settings to control the algorithm, as well as some general parameters here. So first one we look at is the color anomaly detection setup. First question is, hey, do we want to enable color anomaly detection or not? And as you see, much like on the image analysis side, almost all of these inputs will include tooltips in case you're curious about what something does or don't remember what something does. You can pull up the tooltip and that will tell you exactly what it is set for. Next, we have the color rarity settings. So behind the scenes, color anomaly detection is very much akin to the MR-MAP algorithm in that it relies on quantization of the colors, so basically simplification of the colors, and then identifying colors, those simplified colors that are infrequently found in the image. So that's really what these next two settings do: color resolution bins and rarity threshold. Color resolution bins basically is, hey, how much do we want to simplify the color space? And rarity threshold is, once it's simplified, how many pixels have to be in the bucket, or by percentile, how many pixels need to be in the bucket before something is no longer considered rare. Min max object area, all based on the parameters that we set up in this case in the setup wizard, or you can of course change it here. Next we have blob detection method. Now this one gets fairly technical, but really what it boils down to is, behind the scenes, what mechanism do we use to identify anomalies or areas of interest. Below that we have our color space options. We can do anomaly detection in RGB, HSV, or lab. Then we have color match expansion, and this allows us to go a little bit from color anomalies into color detection. So how this works is, if it's toggled on, we'll find color anomalies, and then we'll look for things that are in a similar hue range. So for example, if it finds an anomaly that is somewhat pink in nature, it'll look at neighboring pixels in that area to see, hey, is there anything else in the immediate area that resembles this color, and include that in the same detection. Finally, on color anomaly, we have the ability to exclude certain color ranges. So if we turn that on and said, hey, we don't want to include anything that's green, this is all heavily wooded area, we know the person wasn't wearing a green backpack or green shirt or whatever, we can go ahead and turn off the green space or any others that we want. Next up, let's look at the motion detection settings, and we break this down into two parts. And I should note, as we look through this, we can get very specific with a lot of these settings, but know that there are reasonable default set for all of them. So if there's something you don't understand, don't feel like you need to change it until you really understand what it does. The settings should work pretty darn well as it is out of the box based on our experience. So first question, of course, is do we want to enable motion detection or not? Then we get back to our min and max object area. How big of an anomaly are we looking for? Do we want to pause the camera on movement? So to a computer, the camera moving looks an awful lot like something within the frame moving. It doesn't really have a way to differentiate. It's not looking at the velocity of the drone or an accelerometer or anything like that. All it knows is it's seeing movement in the frame. Well, if you do that, if you look for motion detection, the camera itself is moving. Everything's going to be an anomaly. So if you have motion detection enabled, you more than likely want to have it pause on camera movement. And only when the drone is stationary do you want it to really be doing that motion detection process. And that's what we set here. And we set, hey, only do this if the camera is paused, and then the threshold for what counts as paused. And really it's what percentage of the frame needs to be still before something is considered paused or not. Next, we have a bunch of advanced motion settings. Again, these are not really things that you're going to need to mess with unless you're really familiar with video algorithms and motion detection algorithms and computer vision and that whole side of things. So I'm not actually going to cover these right now, just in the interest of time. But now, again, as always, you can come in here, mouse over these, see what they are. You can read a little bit more about them in the user guide or on the website and start experimenting with those as you see fit. Next, we have our fusion parameters, and this is where we start to marry the color anomaly detections to the motion detections. And we have a few modes to do that we can use for that. We can do a union. Let me pull up the tooltip here. Union shows all the detections from both. Intersection only shows detections where those overlap, or color or motion priority, which, as you can see here, just gives a bias to color-based detections or motion-based detections. The last three tabs here are shared by both color anomaly / motion detection and the color detection algorithm. The first being input and processing. This is where we can set our resolution and where we can also set our frame rate. So as you see in the tooltip here, same sort of reasoning as changing the resolution. We can reduce the frame rate, which makes things a little easier on the CPU and reduces the load there. Then we have the option to render at processing resolution. This gets into as we're downsampling or downscaling and upscaling. There's some expense there. Do we want to do that or not? Frame. So this is useful for instances where you have watermarks or something else going on in the video. So for instances where you're streaming from a controller and it has markings around the outside, we can tell the algorithms, look, ignore that stuff. Like, even if it's green, then don't count it as a green detection. There's no way for the computer to know implicitly, hey, this isn't actually part of the video, it's just part of some overlay from the controller. So the framing allows us to set a buffer and say ignore everything that is within, in this case, 50 pixels all the way around. Or if we want to get really specific, we can input a mask image and basically say, hey, anything that is black gets excluded from the image or from the processing. So basically, you give it a mask that represents what your controller output is and tell it ignore this part of the screen, ignore this other part of the screen, ignore this part of the video, and only do detections in whatever is left. Finally, we have rendering and cleanup. And this is where we can set, hey, what shape do we want to use to show areas of interest in the augmented video? We can show some visual options on what we want to include in the overlays or in the annotations on the screen. We can set a max number of detections, again, kind of helping the CPU here. The fewer detections that it tries to render onto the screen, the better the computer is going to be able to cope with that. Temporal voting. So this is a mechanism for reducing some of the flicker as you start to stream the video. Detection cleanup. So this is where we'll often run into situations where we're looking for detections that are, more regular shapes or denser shapes, I would say. So it's kind of the rivers versus lakes scenario. If we want big blob detections like a lake, then we set this or use this and set the aspect ratio appropriately. If we want detections that kind of meander and it's loosely connected dots, then we can go ahead and leave this off. And finally, detection clustering is the mechanism for combining areas of interest if they are close to each other. Below all the algorithm controls, we have our recording section, so less pertinent for files, but for HDMI capture, RTMP stream, basically those live data streams. Recording gives you a mechanism for saving that video so that we can, saving the augmented video so you can play it back later. It also enables us to use the gallery feature because we need that recording in order to go back to it. So in the gallery, if we, again, want to say we're looking for, or we saw a detection at 33 seconds, well, if this is a live stream, then we really need the recording to get back to 33 seconds, if that makes sense. All right, we're going to go ahead and look at the rest of the features once we go ahead and connect the video here. So I'm going to go ahead and click connect, and we'll see, because this is a file feed, we have the option to pause, play, and move within a timeline. But more importantly, let's back it up here. We'll see that it is immediately detecting an anomaly up here in this excavator that is doing some work up in the top portion of this video. We see the augmented video frame here. We see the detections in the thumbnails down here. We see a readout of the detection in the information section here. And if we continue on for a little bit, still really liking that excavator. If I go over to the gallery, we see in frame 2, frame 3 that it has that saved for us, and we can go back to it and it will circle that for us. So we can go ahead, continue playing there. And again, we see as the video moves, I have motion detection turned off right now. Otherwise, we'd see a message saying, hey, can't really use motion detection while the camera is moving, but it continues to track that anomaly for us. Now let's go ahead and take a look at the color detection algorithm setup. So there are two tabs here that we're looking at. There's the color selection tab and the detection tab. A lot of what we'll look at in color detection is similar to what we saw in the setup wizard. Let's go ahead and add a color. Let's add it from the HSV color picker. And let's say we're going to try to find that same excavator. I know we're going to find a whole bunch of stuff here because we're looking kind of in that green space, but hey, it'll at least give us a bunch of detections and see what that looks like in the augmented view. So we click add color. Again, we can also pick from an image, we can pick from a list of common colors, or we can use any recently used color from previous detections. If once we add a color we want to modify it, we can click on the color swatch here, and that brings us back into the HSV color selector or color range selector. We can also modify the ranges directly in the interface here. We can set our hue range in degrees. Again, the cautionary tale, again, since hue is a circle, if we have a hue that basically straddles somewhere around the red range, it can go basically around the circle. So this range at first glance may not make sense because it goes from 318 to 32. But what that really means, it's going from 318 past the 360/0 point onto 1 and then up to 32. So as long as you Remember that we're looking at hue as a circle here. It kind of makes sense. Saturation and value are measured in percentages, so 1 to 100 essentially is the range of possible values for those two. We'll go ahead and remove that. And then let's look at the detection tab. So on detection, we set our min and max object areas, and then we can set our confidence threshold. And really this is a scoring mechanism based on size and shape. So back to our lakes and rivers analogy, is it a condensed shape, a dense shape, or is it kind of an anomaly? Well, sorry. Is it a condensed shape, or is it more like a river? Is it meandering in little forks going off all sorts of directions and not really a condensed shape like that? And then size is kind of self-explanatory. Basically what we're trying to do with confidence threshold is eliminate some of the weaker detections just so we don't get too many false positives, especially in a video feed like this. So let's go back to the beginning. Let's start this video. Again, our color selection is in the green space. This might be a little interesting. We might get a whole lot of false positives here, or detections, not really false positives because we're looking for green. So we'll go ahead and hit play, and wow, that's a lot of detections, but hey, you can see how it works here. As it finds new things that are within that color range, it immediately identifies those for us. We can pause. We can go over to the gallery view, and man, it found a lot of things, but the good news is we can scroll through those quickly, just like we used to with, or we can on the image analysis side. It immediately, just with a few scrolls, looking through them, finding, hey, I found this interesting thing here, in this case the excavator. Let's go ahead and take another look at that. All right, that is what I wanted to cover today on the ADIAT streaming analysis side. This is obviously an incredible step forward for us and provides a whole new world of opportunities moving forward. We will absolutely be looking at adding additional algorithms and features in future releases. I'll be bringing in some of the algorithms from the image analysis side that lend themselves well to streaming, as well as developing some additional streaming algorithms that are specific to this sort of media. Thank you very much, as always, for your interest in ADIAT, for being a part of the ADIAT community. If you have any questions, concerns, or feedback, please always feel free to reach out. The email address will be in the description below.